Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have very interesting, tricky, I would say like a relaxing algebra question. X to the fourth power equal to 2 to the power x. We need to find our x. If you have your solution, your answer, you can write your solution in the comments below and then we will check your answer. So it will be really interesting. So first of all, let's take natural log on both sides. This is our first step. Let's do this right now real quick. So we have natural log of x to the fourth power on the left side, and on the right side we have natural log of 2 to the power x. This is our first step. Right now, according to a basic natural log property, we can write this 4 right here. Okay, this 4 will come down right here. So as a result, we have 4 natural log, but with one really important moment. This x can be positive, can be negative, so we need to put absolute value brackets. Okay, equal to, right here we have x natural log 2 with the same property. So we have x times natural log 2. So I really hope you understand this first step. We just take natural log on both sides and we use basic natural log property. Right now let's divide both sides. So let's group our variables on the left side and our constant on the right side. So for this, let's divide both sides by 4x. Okay, let's see what will happen. Let's divide both sides by 4x. When we divide our left side by 4x, so we have 4 natural log absolute value x, we're gonna divide by 4x, yeah, and we have our right side, so x natural log 2, we're gonna divide by 4x. And that's why I divided it by 4x, because right here we're gonna cancel this 4, we're gonna cancel this constant, and right here we're gonna cancel x. So as a result, we have our natural log absolute value x on the left side. So that's why I did it, because right now we have natural log absolute value x. As I said before, we have our variables on the left side over x, and on the right side we have natural log 2 over 4. So this is our first step. We just group our variables on the left side and our constant on the right side. Right now, really important moment, because absolute value can be positive and can be negative. So let's consider our first case when x is positive. Let's do this. So when x is greater than 0. Whenever x is greater than 0, we're going to have absolutely the same thing, but without absolute value brackets. So as a result, what do we have? Natural log x over x equal to natural log 2 over 4. How can you solve this question? Of course, with knowing of Lambert W function. This is extremely important function nowadays. How does this function looks like? For example, we have expression like a times e to the power a. This I tell you right now the basic identity, basic formula. So whenever we have this expression, whenever we put Lambert W function, as a result we have only our a. Okay, so this is the main key moment, because we need to have this type of expression. For example, we have, let's try it. So we have like 8 times e to the power 8. So whenever we put absolute Lambert W function to this, as a result we have only our a, but a equal to 8. So we need to have the same expression right here and the same expression as the power of e. This is extremely important part, because right now we're gonna create this type of expression on the left side, but we don't have a e. We have x. So instead of x, let's write e to the power natural log x. This is our first really important substitution. So instead of x, we can write e to the power natural log x. Okay, let's do this. So instead of this x right here in our denominator, we're gonna write e to the power natural log x. Let's do this right now. So we have natural log x over e to the power natural log x equal to natural log 2 over 4. Right now, we need to bring this from our denominator to numerator, but we know how can you do this. Of course, right here we have this property. Whenever we have 1 over a to the power b, we can write it as a to the power minus b. So we need to put a negative sign right here. As a result, what do we have? As a result, we have natural log x times e to the power minus natural log x equal to natural log 2 over 4. Really great. So I really hope you see right now that we have something common, okay, with this one and with this one, because we have e and we have looks like the same expression, but with a little bit difference, because we have right here minus and right here we have plus, but we need to have the same expression right here. We need to have e, we have it, and we have minus natural log x. So for this, we need to multiply both sides by minus 1. Let's see what will happen. So we're going to multiply both sides by minus 1 or divide, doesn't matter. As a result, what do we get from here? We have minus natural log x times e to the power minus natural log x equal to minus natural log 2 over 4. And right now, really great moment, because we have minus natural log x and we have minus natural log x, so we have the same thing right here. So for example, this is our a, and of course right here we have our a, so we have a times e to the power a, so expression that we really need to apply a Lambert W function. Okay, so right here we have it. We have this main property, and we can easily do this right now because we have something common with this formula. So as a result, we have Lambert W function of minus natural log x times e to the power minus natural log x equal to, but don't forget about right side because we need to apply Lambert W function on both sides. Lambert W function of minus natural log 2 over minus natural log 2 over 4. Right now, really great moment because we have, as I said before, we have expression that we really need to apply Lambert W function. We have a times e to the power a. When we apply Lambert W function, we have only our a, but a equal to minus natural log x. So we have minus natural log x on the left side, minus natural log x equal to this one, Lambert W function of minus natural log 2 over 4. This is our right side. Don't be scared about this right side. This is our basic, and this is our constant. Don't be scared about it. This is constant, and also this is a constant. So don't be scared about our right side. Let's simplify this a little bit. First of all, let's multiply it by minus 1. We need to find from here. We need to find this x. So for this, let's get rid of this minus. So that's why we multiplied both sides by minus 1. So we have natural log x equal to minus Lambert W function of minus natural log 2 over minus natural log 2 over 4. Really great. And the final tricky move, we need to find our x on the left side. But how can we do this? First of all, we need to create base of e on both sides. So first of all, base of e on the left side with the same power, natural log x. And on the right side, base of e of this expression. So we write this expression in our powers, but creating base of e, okay? So minus Lambert W function of minus natural log 2 over 4. Really great. And right now, e to the power natural log x, we have absolutely the same thing. You can easily see it. E to the power natural log x equal to x. So as a result, on the left side, we have only our x. On the right side, we can write it in our denominator. We have a negative power in our numerator. We can write it as 1 over e to the power Lambert W function of minus natural log 2 over 4. But few really interesting moment. Okay, this is our answer. I agree with it, but this Lambert W function has a lot of indices, so we need to put this n right here. And whenever you plug in this expression on your internet library, of course, I don't think you're interested in it, but I find it for you because I plug in this function in internet library, and this function in this with this index, you're gonna have index 0 and index minus 1. So as a result, we have two roots. So this expression gives us two roots. So the first root, x first equal to 1 over e to the power Lambert W function with this index 0 of minus natural log 2 over 4. This is our first root, and of course, if you're interested in this, I find it this approximately answer. So this approximately equal to approximately equal to 1.239. These are x first, and of course, this Lambert W function will have the second root. We're gonna have the second branch, 1 over e to the power Lambert W function with the index minus 1. As a result, we have minus natural log 2. So the same thing, but this Lambert W function has a lot of branches, so it's not like this is one and only one root. This is like a general case. How can we write our root? But as a result, we have two branches. The first branch is when we find this Lambert W function. In this point, we have first branch with this, and we have the first root, and we're gonna have the second branch, and as a result, we have the second root. And if you're interested, x second equal to 16. So when x, so right here we have it. When x is positive, we have two roots. We have x first equal to 1.239, and we have x second equal to 16. But don't forget about the second part, because x second can be easily equal to x can be less than 0, and that's why I'm gonna write the second part of a solution right here with the new paper. As a result, as I said before, we're gonna have the second part of solution, and when x is less than 0, I don't want to solve it once more because it will be like a long video, but when x is going to be negative, we will have absolutely the same solution, absolutely the same thing, absolutely the same principle, everything is absolutely the same, but with one minus right here, we're gonna get rid of it, we're gonna avoid it, we're gonna sometimes we're gonna have plus, so absolutely the same solution, so it will be like a long video if I do this. But right now this is like your homework. If you wanted to practice Lambert W function, you can easily solve this question when x is negative, so you will have absolutely the same thing, so don't worry about it. And right now when I plug in it, when we have x third, let's do this. So x third is equal to 1 over e to the power Lambert W function of natural log 2 over 4. So as I said before, absolutely the same principle. As you can see right here, when we find when x is positive, we have minus right here. When x is negative, we don't have this minus. So absolutely the same principle. I really hope you get it. And when we plug in it in our calculator, we're going to have x approximately equal to minus 0.8861. So we have three roots. When x is positive, we have 2 roots. When x is negative, this is like your quick homework. Don't worry about it. You can easily solve it, because I don't want to waste your time solving this type of expression once more with one difference, with this minus sign right here. We don't have it. Right here we have it. So I really hope you get it. I really hope you understand it. And right now let's write our final answer to this question, and then we will check our answer real quick. So our answer, of course, I can write this general case, but you can easily see it. I just write the approximately answer. So this one, and this one. Of course, you can see how it looks like if you're talking about general case, because sometimes happen that you don't allow to use a calculator on your exam, and that's why this is what you need to write, because you can't use your calculator, and that's why you can get this exact value. Okay, but right now I'm going to write it. So x first equal to right here we have 1.239, x second equal to 16, and x third, of course, right here we have absolute approximate value, yeah, minus 0.861, and right here, of course, approximately value. So these are our 3 roots. Right now we can easily see a graph. You can see these points of intersection. You can see this like from geometric perspective, but in the end I just wanted to check this x second equal to 16 without a calculator. Of course, you can easily check these 2 roots with a calculator, so everything is up to you. Right now let's check it real quick. Let's check it real quick. What do we have in the beginning? X to the 4th power equal to 2 to the power x. Let's check real quick x equal to 16, because we can easily do this without any problems. We have one integer solution, so let's do this real quick. So we have 16 to the power 4 equal to 2 to the power 2 to the power 16. And how can you do it? There are a lot of ways how can we do this, but the main one, we can easily create base of 2 on both sides. Right here we already have it. On the left side we can write it as so 16 equal to 2 to the power 4 raised to the power 4 equal to 2 to the power 16. As a result, we have 2 to the power 16 equal to 2 to the power 16. So this root is great for us. This one I can't check it because we have a decimal value. So if you want it, you can easily check it with your calculator. So I really hope you understand it. You already seen a graph. You see this point of intersection, so I really hope you understand my solution. Once more real quick. First of all, splitting both parts by variables and by constant. Secondly, we have x is positive. When x is positive, we have right here, so I don't have a space with this paper. Yes, right here we have x first equal to, when x is positive, we have 2 roots. When x is negative, this is like your quick homework if you wanted to practice Lambert W function. Absolutely the same thing, absolutely the same algorithm, but without a minus sign. So that's why you can easily check it real quick, check your Lambert W function knowledge. And final answer, 3 roots. And you know, a lot of students might be thinking, a lot of students try to solve this question by inspection. They say, okay, x to the 1st power equal to 2 to the power x. And you know, a lot of students find this x equal to 16. They solve this question like that. They solve this question by inspection real quick, and they find this x equal to 16. But with the inspection method, you can't solve this question. You can't solve the question fully, and you can't find x first and x third. This is an extremely important part. So if you want to solve this question by inspection, don't forget about that in terms of fundamental theorem of algebra. So whenever you have x to the 4th power, as we have right here, this is our question. Yes, so whenever you have expression in your equation like x to the 4th power, you need to know that in terms of fundamental theorem of algebra, you're going to have 4 roots in total. So 4 roots in total. Of course, you can easily have 3 roots, you can easily have 2 roots, but the maximum number of root, the maximum amount of root is 4. So you can easily have 2 complex roots, 1 real, and a lot of this combination. But don't forget about it. And in 99% of cases, when we have x to the 4th power, it's not like you have only 1 root, only x equal to 16. You need to do a quick research. How can you find all possible solution? So thank you for your time. I really hope you understand my quick lesson about this question. I really hope you understand my solution. If you still have any question, write a question in the comment section. It's my pleasure to answer you, to discuss a little bit about this question, and to, of course, maybe a lot of teachers, a lot of students watch my channel. So it's really interesting to see how can you see this question from your perspective. It's also really great to see different angle of different points, you know. So thank you for your time. Wish you all the best in your life. Take care of yourself. Also, don't forget to write to respond. I really appreciate it. So thank you everyone for supporting my channel. Thank you everyone for watching my videos. I really appreciate it, and take care of yourself. Have a great day, and see you in the next videos.